All right, welcome back to the SafetyPro podcast. Before we get started, big shout out to our partners in safety, Mighty Line Floor Tape. Go to mightylinetape.com/podcast. Get a free sample of their floor tape if you need to mark out your facilities to keep your workers safe. That's where you want to go, the official floor marking tape of the podcast, mightylinetape.com/podcast. And of course, our official safety services provider, Aero Safety. Go to aerosafetyus.com and get a quote from Drew and his team. I mentioned that we sent you. You get 10% off. They got you covered. Everything from inspections, training, custom written programs for your company. aerosafetyus.com. Thanks, you all, for your support. All right, we are joined once again by our friend Alex Paradies from TapRooT. How you doing, Alex?
Fabulous. I'm getting over things, but I'm a little healthier today, so I'm good to be here.
Yeah, I had it as well, and oddly enough, I picked it up in Nashville, in the great state of Tennessee. What do you got going on down there, for goodness sake?
We are the dangerous state of Tennessee right now, for the flu at least. So.
Yep. Well, hopefully spring will be here. We'll be out of this nasty mess. So we were texting and we were talking about topics. And are we still good with the history of, this is how we wing it here on the SafetyPro podcast. We're still good with the history of RCA, because that fascinated me, that being a nerd, talking about how RCA has developed over the years.
Well, I don't know if it's called winging it. I have two different books of notes, so if that's winging it, then we're winging it. But I've got a lot of notes over here, so I think we're good to go.
We'll call it winging it.
I re-pulled up my research on it and did a little organizing. So,
as long as one of us has done research and is organized, that's all that matters.
All right, well, we're good then.
That's all that matters. So let's start with the beginning, right? Like, take us as far back as you can. When we're talking about the history of RCA, how long of a history are we talking about?
So, depending on how you look at things, we're going back into antiquity. We're going back into early history. The oldest thing I have is from 1750 BC.
Wow! So when you said history, you weren't kidding.
Yeah, we're going way back. So I like this one for a reference on here. It's the oldest customer complaint in history.
What? The oldest Yelp review we found.
It's pretty close to that. It's a clay tablet from Babylonia, and it details a customer complaint from this guy named Nani, and he's yelling at this merchant named, and I would never be able to say it right, but it's Nasir, about the quality of copper. And he's complaining because he was told he was going to get really good quality copper, and when he sent his person there, they were only given bad quality copper. And they're complaining about this. It's the oldest historic customer complaint. So I kind of reference this as maybe a starting point, at least from our history of RCA, because when we think about why we're doing root cause analysis, or why somebody would be doing root cause, it's because they've identified a problem and they want to fix it. And so we don't have the follow-up stone tablet from these two merchants, but you can just imagine that something had to have happened, something had to change if they wanted to continue that relationship. So that's probably the oldest, is going all the way back there. There's definitely things that happen between this and the next, but the next reference point I have kind of starts into the actual philosophy of root cause analysis. So we take from 1750 and we're going to jump 1,000 years into the future to 450 to 300 BC. So we're at 450 to 300, we're talking the Greek era. This is Socrates, Plato, and Aristotle.
Or as Bill and Ted would say, Socrates.
Socrates, exactly. So this is kind of a philosophical approach, and the idea that they were talking about was cause and effect. And so the underlying of root cause analysis really starts back in philosophy with the idea of cause and effect, the idea that you could see a cause that creates an effect. And if you then saw that effect again in the future, you would know what had caused it. And so this early philosophy idea of cause and effect is pretty much still in use today when it comes to root cause analysis.
Yeah, I mean, it's pretty foundational. I mean, but I guess this would be an example of hindsight bias, or I don't know if it's hindsight bias. But I mean, we kind of already know this now. It's commonplace. But if you think about at that time, nobody thought in these terms.
Yeah. You had to be cutting edge at some point, and cause and effect, early cause and effect, very simplified cause and effect. That's kind of the start of RCA, and this is really from the Western philosophy.
Right.
Again, I don't have detailed research going into Eastern philosophies and when they might have had some sort of RCA model. Most of what I'd reference would kind of come out of the Western root cause analysis model, because that's where the terms came from and the industrialization came from. Mm-hmm. So early, we've got cause and effect. Now, the philosophy of the Greeks gets then passed into Europe and European culture, and they do this study. It kind of becomes the accepted practice, cause and effect, scientific method, and the you fall into early Renaissance period science, and they're still pushing the same cause and effect kind of mentality. You get into the 1700s, so again, we're jumping a huge swath of time, right. And you start to get philosophers to push back. And so David Hume, who's a Scottish philosopher in the 1700s, he writes this criticism of Socrates. And his criticism is that you can't assume because you saw a cause and effect once that's the same cause and effect the next time. There can be multiple causes that produce the same effect.
Right.
And this was an early criticism of cause and effect as a philosophy, to say, there's a weakness here, that just because it caused and affected this cause and effect chain happened once doesn't mean it's going to be the same effect chain every time. So
that makes sense as sort of the single theory cause of multiple types of events. Both things can be true, but you have to prove it. Like, I think what's getting lost in this discussion, and I don't want to jump ahead, but is there is a process of validation process, a discovery process that we're missing. It's so far it's very simplistic right now, right?
Yeah. So the early pinnings of this cause and effect, again, kind of tie into those early, we'll call them the same as early science days, right? Where a lot of, fundamental science and research was starting to be done, but it starts to move from this philosophy or philosophical mindset for cause and effect to starting to be more on the practitioners. And this kind of leads into the Industrial Revolution. And again, as the scientific, fervor begins to push in this mechanization, we start to get mass production. And with mass production comes a new form of war. And we see that with World War I, becomes the first really industrialized war.
Yeah, the mechanized war, really.
Yeah. It's the first industrialized, mechanized war. And you start to see these early problems of large industrialized war, because you've got factories producing, vehicles, weapons, munitions, supplies. And so this is kind of that early period of problems in our war due to mass production and mass distribution. But again, everything was very early, and so most of this was just handled and shipped and dealt with at the time for World War I. But you see, between World War I and World War II, there starts to be kind of a statistical process to begin to be applied. And this is where you get a lot of different mathematicians starting to come into the mix.
Yeah, Deming I'm sorry,
Schuhart.
James. Oh, yes. Yes.
So before Deming, you get Schuhart,
yeah.
And he's kind of the grandfather of statistical process control. And so he worked for Bell Labs, and his job was to improve communications. Bell at the time was the monopoly Bell, and so he needed to improve phone communications. He had to look at reliability of the network. He had to look at the quality of the basically the receivers and the microphones, if you will, at the time.
Yeah.
And looking at the quality of those and how do we improve that quality to make sure that people can hear things better. And so he started the process of statistical process control. And this has the idea of common causes and special causes. So that in any process there is a normal variation, and there can be special causes that make things go outside of that normal variation.
Yeah.
And so
like an anomaly, if you will.
Exactly. And so the idea of looking for special causes. So somewhere in this time period, Schuhart he kind of starts doing this course on SPC and control charting. And this guy Deming, this is where W. Edwards Deming comes in. He's working for the Census Bureau, and the Department of Agriculture and the Census Bureau. And he decides to get the government to attend this course by Schuhart. And this kind of begins this process for him of, hey, how do I take this process control idea and how do I simplify it? In Deming's words, Schuhart had this remarkable talent for making everything really complicated. And so he has this opportunity to take this knowledge and simplify it. And that model for him, he called it the Schuhart cycle. It then becomes the Deming cycle, which becomes PDSA.
PDSA, yeah. Before it was what we know it now, right?
Yep. So it was Plan, Do, Study Act back then. And this is where you can kind of see the birth of the modern quality system was in this time period right around World War II.
Yeah. And
so he kind of brings in this statistical process control into the U.S. military, and that's right at the beginning of World War II. So World War II starts, and the U.S. military is ramping up production. We're supplying munitions overseas, and then we eventually get involved in the war. Well, we start to have problems coming up with munitions. So you don't want a bunch of dead rounds going out to soldiers. And so they start to create what they called mil specs at the time. Mm-hmm. And they create these standards. One of them was FMEA, failure modes and effects analysis. Mm-hmm. And this comes up and is early developed in World War II and is rolled out as a way to work with suppliers to develop and identify these failure modes. Well, at the end of the war, the U.S. starts to expand and work to rebuild the countries that we've, bombed and destroyed and attacked, and now we're
other countries. Yeah.
All of these other countries we did this work with. So some of them are our allies. So there's a lot of sharing of information between allies. You see NATO specs and these ally specs happening in Europe and UK.
Yep.
And then Deming, he goes with the census to Japan.
Japan, yeah.
And in Japan, he introduces these statistical models to different people and groups in Japan, it gets picked up by two major groups. One is Toyota.
Toyota, yeah.
And the other is Ishikawa. So Kaoru Ishikawa, that name should sound familiar to some people. They hear Ishikawa diagram. Or fishbone for the Westerners, right? Fishbone. So you kind of start to see Japan adopt these process control models. And they kind of create their own culture. They have a very, disciplined culture, and so they can take process control models and turn it into a very disciplined process. And this is kind of leading post-war. We're talking now in the 50s and 60s here. And in the 50s and 60s in Japan, they're doing things like the 5 Whys, fishbone. You start to see early lean things like the judoka, which is the idea of automation and building quality in the machine. You start to see the applying to things like for fishbone, you see kind of the 6M method for fishbone. Yeah, so they start to categorize those bones in the fishbone. And so the 6M, that is man, machine, method, material. Depending on it, you say Mother Nature. And measurement. That's definitely starts evolving, and I've seen 10M recently. I've seen 8M. They throw in things like management, maintenance. They come up. You just keep coming up with categories. It'll be 20M by next year. So,
it'll be a big fish.
It's a big fish. The fish grows. The ends keep growing, just like every fish when you tell a story.
Like every fish story you tell.
So we start to see these methods of categorizing, and I think it's an interesting thing where you can kind of see this change from philosophy to application of cause and effect. And it coming out of kind of this wartime process-based, we've got to control. Also in this wartime time period, again, we're talking the 40s, you also see this other element begin to grow as well. That's not cause and effect necessarily, but it's human performance and human factors.
Yeah.
And so during the war as well, they started to look at training of pilots. And one of the things that was noticed is we were losing more pilots during World War II in the training period of pilots than we were in the actual, losing them to dogfights and missions. So we were having a bigger problem of training people to fly than we were actually executing on missions once they were trained. And so that mystery began to develop into an entire study of human factors and study of why people make mistakes. And so we kind of see this development of a discipline begin in that 50s and 60s time frame. A lot of research starts to be done on human factors and how people make mistakes and how do we set up systems for people. So you start to see that development and knowledge base start to grow coming out of World War II. So 50s and 60s, you've got this Japanese movement that's starting to happen. In the U.S., there's a similar movement happening for cause and effect, but we see it a little differently in the U.S. Again, you're seeing from the military kind of supplier base spread in the U.S. So companies like Ford and other automotive companies are doing a lot of statistical process and looking at what they were doing at the time, which is very similar to what Deming had learned for PDCA and stuff from their own processes for root cause analysis. You start to see things like Kettner-Trago, which was a management philosophy for problem solving. It looks at situation appraisal, problem analysis, decision analysis, and opportunity analysis. So it was kind of a decision-making model for improvement. So that kind of starts to get us how do we manage these challenges and look for problems and improve. So
is some of that like the 8D or the 8-step decision making process that kind of came out of the military is still used, I think.
Yeah. So the early stages of it exist there. 8D doesn't really show up in its form until the 80s.
Got it. Yep. I think Ford was the first American automotive company to actually bring Deming in. I mean, at some point, right, in the late 70s, early 80s.
Yep. So they bring him back to kind of show him their stuff. It's really what if you look at that, it ends up being they're like
it was more of a look what we did.
Exactly. It's hey, well, when you look at the history of like lean stuff, again, a lot of this a lot of the Deming and the Schuhart stuff was being applied at U.S. companies like Bell and Ford in that early, 20s, 30s, 40s. Deming brings this over to Japan, and it gets pushed from there and comes back to the U.S. in the 80s.
Yeah, sort of kind of this boomerang effect, right?
Yeah.
I mean, it was wildly successful in Japan, and I think, correct me if I'm wrong, this is my assumption, just me reading into this, it's a combination of things, because Deming tried to do some things in the States. I mean, he ended up almost having to go to where, all right, if this is going to work, if it's not broke, don't fix it kind of mentality here.
Yep.
Someplace like Japan, they were open to this because they were starting over in large respect, right? In a large part, because it was post-war reconstruction, and they were, and you mentioned the culture was tuned to this. It's a very disciplined culture. I've got a lot of respect for that culture, and so it was sort of like the right idea with under the right circumstances at the right time with the right people.
Yeah, and if you look at people like Taiichi Ohno and Toyota, and I butcher his name, which is Sakichi Toyota. Both of those guys were very much. Toyota was realized he needed to change what the business was doing, and there was an opportunity for automobiles, and that was their change there. And Taiichi Ohno was, at least by accounts that I've read, a very particular type of person, which means it has to be done a certain way or else it's wrong. And even if it works, it's still wrong because it wasn't done the right way. And so, I think those two created a culture that really soaked this up. And, as a country culture, it spread very much academically in there. And again, that's where Ishikawa was really more on the academic side. So they were like, yes, this is exactly what we want to push forward, standardizing, following this rule, following this process. So that was very much a cultural zeitgeist there in Japan. But I don't want to pass up exactly kind of the similar things that are happening in the U.S. because if you think about, again, we go into kind of 60s, there's a lot of stuff that starts to get developed in this time period and going into the 70s. And so when we get into the 70s, and from a U.S. history standpoint, OSHA, EPA, MSHA, all these regulatory begin cropping up, and they come because of these large disasters, essentially. If you look at like process safety, environmental, and mining disasters, we really had some high publicity type ones that occur in that 60s and 70s time period that lead to the creation of these regulatory. And so because these regulatory bodies exist, they start to put pressure for this need for improvement, to recognize what happened and what we're going to do. And so you start to see additional tools start cropping up in this time period. So ones that we kind of feel are relevant in this, at the NTSB, there was a man, and I cannot get his last name right, but his first name is Ludwig. Let's see if I get it in my notes here. No, I didn't write his name down in my notes very well, but it was Ludwig. I think it was.
It feels like a Vaughn has to be in there with that first name.
I don't think there's a Vaughn in there. I think it's Ludwig Brenner.
Ludwig Vaughn.
Benner, BENNER, I think is what it is.
Yeah, the National Transportation Safety Board, right?
Yep. NTSB, National Transportation Safety Board. Well, he works for them, and he creates this process called multilinear event sequencing. Mm-hmm. And the idea for this was when you had something for air disasters, things like that, we're dealing with transportation disasters, you really needed to sequence out really the logic along this timeline of what happened and what actions occurred.
Bless you. So it's very linear at this point, right? Trying to chart this timeline.
Yep.
Right.
So he's building out a linear sequence of events, and it's actually, if you ever see the old pictures of it, it's kind of like you see these little ticking things because it's all about action and connection between who's taking what actions, so that you can kind of see the actions that went along. And this gets spun off, and it gets spun off by the Department of Energy because they're looking at the nuclear industry, and they want to have a system for evaluating problems that occur in the nuclear industry. So Department of Energy, highly regulating the nuclear industry. And so they take this and spin it off, and they kind of create a couple standards that is used in the nuclear industry. One is events and causal factor charting. The second was MORT, and the third was barrier analysis. And they kind of popularized these three techniques and standardize it in the nuclear industry. And so you kind of see those coming up in the 70s and kind of rolling out across the 80s in the nuclear industry. Well, that's a very specific niche group of people, nuclear energy. Right. At the same time, you kind of see going into the 80s, you see a lot of management books kind of rolling out some different ones where you see this is where 8D kind of gets launched into the market for kind of, and I'll describe it as Ford saying, "Hey, look, we did this stuff too," because
quality was job one back then for Ford. That was their motto. Remember,
yep.
I remember the commercials.
Yep. So Ford and Motorola are kind of two big names in the quality space. Motorola, Bill Smith was talking about Six Sigma. So that was kind of rolling out there, and that was for people who don't know Six Sigma. That's basically it's saying a process shouldn't produce more than 3.4 defects per million opportunities. So 6 standard deviations between process and the nearest specification limit.
And that's how we get the title.
Yep, that's how we get.
A lot of the titles are either acronyms of what it does, or just what it does.
Yeah, just what it is. It's Six Sigma, so that's what you should hold Six Sigma in yours. And so that was very much. I kind of think of that Six Sigma as a logical conclusion from specific, process control (SPC), because the idea is, hey, how do we detect these defects, and how do we understand, apply scientific principles to turn them on and off, prove that you understand them, and then fix them.
Yeah.
So very much you start to see a bunch of people handing out belts for Six Sigma in the late 80s.
Because it was an Eastern, they adopted the Eastern,
I think they went into too many karate classes, but anyway.
They put a theme on it, really.
Yeah, it was a good
I got my Lean Six Sigma green belt. I remember when I got that. Yeah, I mean, I didn't actually get a belt, but
no, they just threw the title. So you start to see that the early 90s, that one's becoming popular in there. Late 80s, again, we see Ford's starts to share its 8-step problem solving method. And you can see that one has a lot of similarities to kind of from the lean side. It has its own 8-step problem solving. They're very similar, and they kind of come from the same root. TapRooT, we come about in the mid to late 80s. You see our process starting to be developed, and kind of Mark's history on that. He was working at a nuclear site for what is a large chemical company, but they also have nuclear power as well. And so he was working at one of those sites, and they were really looking at, okay, we need to really understand what root cause analysis is, set some standards for this, and really develop a process for looking at the human factors. The human factors tied to root cause analysis.
Right.
And so, that was what their group kind of set out to do, and it's what evolved into basically became TapRooT, coming kind of out of that nuclear side.
Yeah. I want to go back to that here
Sure.
in a moment, just as we get through the timeline, because I'm taking some notes here that I want to ask you about.
Yeah, and so
moments in time.
You get kind of into the 90s, and you start to see businesses start to formalize on a couple different philosophies. So you see Six Sigma starts picking up in the 90s. In about the early to mid 90s, you'll see James P. Womack coining the term lean with the machine that changed the world. That's kind of starts the lean trend in the mid 90s. Mm-hmm. And again, you start to see those kind of philosophies of 5 whys, fishbones. That really starts to popularize those in the U.S. So again, 90s, you start to see in different industries, you start to see different things are popularized. For us, this is where TapRoot's kind of history. In the 90s, we started off kind of in nuclear industry and energy utility, but we actually go quickly into oil and gas. And that starts with Chevron. In a meeting where Mark got invited to go tour a refinery and give a presentation on root cause analysis to the plant management. So he took that up. He left. He was supposed to speak at a conference. He spoke there, then leaves that conference to go do this. Ends up kind of connecting us into the oil and gas industry, and that's where we came through from standard out from that industry.
But again, that makes sense, right? If you think about the trajectory here. Everything coming from a need for it.
Yep.
Right. And that is, you go from the nuclear industry, which for obvious reasons needs to have very tight controls and methods of figuring out why things happen and stopping them before they do. And then oil and gas, chemical industry as well, I would throw in there. These are all regulated under its own standard today, under the PSM standard. There's a threshold that is triggered and you become a process safety management site and you fall under those regulations. So I can definitely see how Mark's background in the nuclear industry, even in the Navy going further back, right? And then taking that from nuclear energy production, utilities and chemical, and then oil and gas. I mean, that makes sense, right?
Yep. And so you kind of, when I look at kind of the pendulum swing on this, you start with this history of philosophy of cause and effect and people trying to understand their world. Then you get into the Industrial Revolution and the necessity for it starts to begin. Because as we produce more and deal with these processes and chemicals and stuff, you start to see the risk level going up. Mm-hmm. And once we've recognized that there's an increased risk level, we start to require and start to regulate. And you start to see this regulation pushing people to meet these standards. And there has to be an understanding of when we deviated from those standards, why did we deviate and what we can do differently. And that kind of becomes the need that grows into different methods that become for RCA. The that there is a need, there is a problem where people make mistakes, problems occur in our facilities, and we need to look for a solution for how to understand these problems and how to prevent them from happening again. And I think that's where a lot of different philosophies came and approached this. There's a large number that continue that cause and effect chain. We're one of the few that kind of took it and said, hey, we need to not just be this cause and effect chain. We do that events and causal factor charting with the snap chart for us, but we recognize that there was also this need for human performance. And I talked about that back in World War II. There's a need to understand why people are making mistakes and the context behind that mistake, not just looking at, well, yeah, a person they were the cause and they had this effect, but looking at all these underlying elements behind it. So the 90s kind of start taking this approach, and you'll see in the 90s, Mark, James Reason, late 90s, really late 90s, Decker, starts showing up in there. And that starts to kind of say, hey, let's look at this human element to this. So we have our own tree there. Reason looked at active errors, latent errors, and things like that. So he looked at errors. You see Decker kind of in the early 2000s really starting to play with this term safety too.
Yeah.
That later gets retooled into New View, which all kind of gets lumped together then in the 2010s into HOP, which is now kind of currently where it's, human organizational performance.
Which is an old term.
Yeah.
Yeah. But I love that. I love that they're like, oh, that's what all this is.
Well, and that history also comes from, and again, we talk the 90s, the nuclear industry coming out of its regulation and looking at human performance. And Mark would give you a whole story between kind of his history involvement in working with IMPO back in the day to kind of set some of those early standards. But that kind of evolution is, I think, still ongoing, because what I've seen now, and I kind of, there's not one era going on post-90s. Mm-hmm. What I see now is kind of a rise and fall of different, I don't call them trends, but I'll call them, it's like flavor of the month for a company. And so, if you look at companies, they might have started at Six Sigma in the 90s, then they did Lean in the early 2000s, and then they did some other combination in the 2010s. And it's like they rotate through these kind of different concepts as they roll them into their organization.
TQM, you throw that in there, if you recall, for quality systems. Total quality management was a thing.
Yep.
So safety had our own flavors as well, right?
Yeah. So a lot of right now is, we work through, they get passed around. So there's not one industry that's got the right answer right now.
Yeah.
And a lot of them are all just trying to learn this new thing from each industry and pass them around. So we've seen kind of a wave of those coming and goings for human performance, lean, and a couple different processes, at least in our experience of working with clients. We've seen those kind of come and go in waves through an organization. Our belief is root cause analysis is not going to go anywhere, because you need to understand what missing best practices you should be applying in your organization, and you need to understand what happened. Yeah. So when accidents occur, you always need to understand what happened, and you always need to understand what best practices you can apply. And so I think most organizations now, from a regulatory standpoint, whether you're talking about ISO 9001 or what, they recognize that you have to understand and be evaluating your failures and your successes. And I've seen that kind of become the industry standard. Now, there's not a good standard process. We haven't saturated the market to be the standard. But
working on it, though.
Yeah, we do our best to try to get everybody there.
I'm trying to do my part as well. But, it's interesting. A lot of this sounds like, for good reason, productivity, quality, focused.
Yep.
And a byproduct, I won't even say it's an offshoot, because we're using the same tools. And man, I just recently was talking to a group, and we talked about the definition of a workplace incident, workplace accident. You know, the textbook definition that is in some variation still taught this way, which is an unplanned, unscheduled event that results in, and in this case, we're talking about injury, illness, or property damage. Unplanned, unscheduled event. Well, an unplanned stop in work, I mean, that's a quality defect. An unplanned, undesigned, defect that gets introduced somewhere along the line. So upstream defect elimination, all these phrases you want to use, we're using the same, you could say, philosophy. I love this operating philosophy. It's the same thing. With safety, we have the added misfortune, and it's terrible, of we didn't just produce a bad part, we injured somebody.
Yep.
So you have that byproduct. But once you tackle that, once you come to terms with that and you treat them and you get them the care they need, and hopefully it isn't that bad, then you get this, it's the same clinical approach. You're just dealing with people in this process of, talking to them, interviewing them, and focusing, like you said, on the human behavior part. It is, I wish it were just as easy as you are working with a tool. Well, let's go analyze this tool, and that's a very clinical, very cold, calculated process. Once you start dealing with a bunch of people and how people do their job and the human factors, you've got to take a whole different approach.
It's not like a failed component, right? You get a failed component, we're going to send it to the boys in the lab. They're going to look at the way it fractured and look at the way it broke down and come up with their,
the metal fatigue, and what foundry did this come from? Where did they source the raw materials to make the ore, right? And go all the way back to say, how can we improve this? With people, it's different. So I think that's why in the safety world, I wouldn't say we've struggled, but it can be a struggle because we're dealing with the human factors, and humans are fallible. Humans can take a really good process or system. Which one of them said it? Was it Deming that said, culture eats process for lunch?
I don't think that was Deming, but
it may have been one of the other ones. And that's true. You could take
humans, somebody in the comments can tell us. They can look that up.
Yeah, somebody in the comments can tell us. Humans can do a lot of damage to good processes. So we have to, I love the evolution of, all right, we now also have to have something that, an operating philosophy, which will produce mechanisms for us to deploy to handle, manage, figure out that human element as well. It isn't just process.
Well, I think that was, honestly, it's the big downside from a lot of the techniques that got developed from purely a cause and effect relationship, is because they end with people making a mistake. Someone pushed the wrong button. There we go. That was the cause. It had that effect. And they end on the person, and that leads to blame, and it leads to looking at people as the problem. Yeah. And I think when you take a starting approach is, of course, someone made a mistake. And instead of saying, okay, person made a mistake, that's the end point in my investigation, you take that as a starting point, and you look at what's the context behind that mistake? What was their training? What was the culture like? What was the equipment setup like? Yes. And when we look at the system that we put people in, we recognize that our systems often set people up for success and failure. And that's where kind of the systems philosophy approach, and there's a lot of ones that are trying to preach on that these days, is kind of that systems philosophy. It's always mirrored with what we've said, which is, you need to look at the system behind the mistake, which is why when we go through the root cause tree, we start at causal factor and we work our way through the tree to find root cause. So we start, someone made a mistake, because of course someone made a mistake. They always do.
Yeah.
People that make mistakes and equipment makes errors. So
I love looking at photos, and you might have a bunch of these. I love looking at photos of old, like, control panels. And you mentioned, like, you hit the wrong button. Well, if you look at some of these old control panels in a dim environment or dirty environment, and it's covered with soot, the start and the stop are the same size. They're the same color, and they're right next to each other. And, like, versus, a big mushroom cap for a stop versus a green switch for go instead of a push button, and then it's on it's in a different area. I love that. I love when you talk about that, because I'm still shocked even today how people, and you come across folks like this all the time. I'm sure you get these light bulbs. You see them go off in your trainings when you do these trainings at TapRooT, of like, oh my God, how did I not figure this out yet? How have I been doing it the other way for this many years, right? Do you get that sometimes, those aha moments?
There's, we call it the Calvin and Hobbes moment.
Yeah.
And it comes from, there's an old panel from Calvin and Hobbes where they're riding on a wagon, and it's like, it's a trouble when you know things, because when you know things, you start to see problems everywhere. And when you see problems, you have to fix them, and change is hard. And so it's like, once you know things and you start to look for problems, you start seeing these things. Yeah. Human factors is like that. When you start to notice human factors problems, you just start seeing them everywhere. There's a couple of them that we laugh at. There's a nuclear control panel, so a panel at a nuclear reactor, and they have all these switches that are exactly identical, and they're basically just a pull-down switch. And they changed them out because the operator had grabbed the wrong switch one time, and so they made a change. And instead of having this generic switch, they had these beer, those little beer handles, like those
like a
tap handle. They had two different tap handles instead of the old mechanical handle that was identical. Now they have these different tap. They had I think they had Miller and Bush or something like that.
They literally switched them out so they could distinguish between the two.
Yep. And
insane.
It's a concept called control coding is what it is. And the idea is that by having different shaped something, you make it less likely for somebody to feel, oh, that feels different than what I was expecting. And it reduces the error. Yep. So there's things like that. There's one, we found this in a hotel. It was pushed, and the sign said, push the green button to exit. And then it had another sign below it that said green button with an arrow, and the arrow went to a big red button. And we found this just in the wild in a hotel. That's a quick picture there. And so
I do that a lot, take photos of silly things. So later, but.
So those are the kind of, you see, like you said, you see that kind of stuff everywhere.
But it's because of what you just said. Once you know it, you don't even have to look anymore. They just jump out at you. And yep. I was walking in an ice cream shop on a trip to Nashville, and we were in there, and the queue line goes around. It's very lean. You go around, you go across the window. It's like the soup Nazi on Seinfeld. You go across and you tell them what you want. You get to the end, pay, and you go out the other end. It's so very lean. But there was an outlet. I mean, I don't even know I don't know why I looked at it, but I looked right at it and I could clearly see. So I walked up and took a photo, and my colleague says, "What are you doing?" And I said, "Look at this." And he's like, "How the hell did you see that?" And I'm like, there's the ground prong busted off in the outlet. And I don't, it's silly, I know, but you're right. You can't not see these things anymore. I'm really upset about the rest of my life.
Well,
I cannot I cannot not see these things.
I'll give everybody in here the one that is the most common for me, and it's called a Norman door. I don't know if we've talked about it before, but if we have, we'll sell it for the people who haven't heard of what it is. A Norman door comes from, I think it's Don Norman. He used to do the interface with the Apple in the 90s. He's
right.
famous for human factors. He's maybe more of an artist than an engineer these days, but anyway, he was big on that, and he had this concept of doors. And he said, You can find problem doors based on when their controls don't match their actuation. So the idea would be, have you ever found a door that was like a bar across and it was a pull?
Yeah.
Instead of pushing, so you ran right into it. Or it has the vertical handle that you would think is pull and ends up being push. Yeah. Those kind of things where you find those backwards doors cause people problems all the time. And door design is some of the, it's a textbook example of bad human factors, because they put these designs that are counterintuitive to what is needed and counterintuitive to what people use. I saw one of them, it was in a house, and they had a bathroom, and you had to open the door into the bathroom, but it would hit the toilet, so they cut the shape of the toilet out of the door.
So you could...
There's a hole, there's a toilet hole. It's like... It's just there's so many. You could have just swapped the things to open out instead of in. We'll fix the problem.
I guess, man. Ingenuity. They probably thought that was the smartest thing they ever did.
Yeah, it was a brilliant solution.
That's too funny. Okay, so real quick before we go, maybe this will set us up for another discussion. I'm fascinated by that whole period of time in history. Especially, not just because I'm a crazy World War II nut buff, but when I remember seeing a diagram used back then of like where they used to assess the planes that would make it back on bombing runs to England, and they would look at all the damage, and they would plot it on a chart and go, well, this is where we need to strengthen. And somebody said, I think you might know this. Somebody said we're looking at it the wrong way. Those are the ones that made it back with that damage. We have to assume the ones that didn't got hit in those other places, right?
Yeah, these are the places
like that.
Survive versus places that you actually would go down if you got hit.
Right, and we need to strengthen everywhere there isn't damage coming back.
Yeah.
So, things like that, we learned a lot. And so I'm fascinated to maybe pick up and zero in on another episode on this, what we learned, some of the studies about human factors coming out of that time period.
Yeah, we can talk about aviation. About cobras and airplanes. Yep, that's a good... Yeah. I don't know if you've heard the cobra story. I'll save it for that one if you haven't. So
Perfect. All right. Well, I wrote a bunch of notes down because I'm fascinated by this stuff. I think this is a good topic, mostly because I'm a nerd, but I get questions a lot because people kind of take this stuff for granted about, like, it should be obvious how to find out what happened. But yet it still escapes today. Right now, as we're recording today, there is a company that is probably leading in their industry. They're not huge, but maybe they're just really specialized and good at what they do. They are struggling with figuring out how to solve what's causing even minor injuries, incidents, or mishaps. And so it isn't that obvious, right?
Yeah, I mean, we've had cause and effect since 400 BC. Yeah. But, I mean, if you really think from an industrialized standpoint, we really haven't been applying the concepts of human error and understanding failure really since maybe the 80s is really when it became kind of standard practice.
Yeah, I remember those. That if I can remember it, I think there's a comedian that, Nate Bargatze, I think. A Tennessee guy, right? So if y'all don't know, Mark or Alex is, and Mark, you're all from Tennessee, right?
Well, Mark's not originally, but we all live here in Tennessee currently.
We all live in Tennessee, so that counts. Anyway, he said he has to remind his kids sometimes when they're talking to him, his daughter, or I think is what he was saying, or something about his daughter. I have to remind them sometimes, I have to do this with mine, that, hey, you're talking to somebody from the 1900s. So that's it. I remember the 80s, and I remember some of these things. And the other thing you said about all these different management philosophies where it was huge. You wanted to make money in the 90s, write a management book, even a bad one. Somebody's buying it, I guarantee you. I would go when I was doing consulting in the early 2000s, when I had that decade, I was doing that. I remember I made it a habit of going into the clients, I'm meeting the client, immediately start asking some of the managers, hey, what books are they making you read? Like the VP of manufacturing, the CEOs or whatever. They're making them read books because that was a big thing back then. Is I'm going to make my team read this book, and this book is going to change the way we do business, right? Now, one book, I would say, which books are you reading? And I would go and try to read them because that helped me understand sort of their headspace, where they are, and why and how they're approaching certain problems in business. I read so many stupid books.
I used to, and this is growing up kind of thing. Mark used to listen to business books constantly, so I had to listen to them as a kid. But when I was in industry, I got to interview and talk with VPs and kind of question them and stuff. And I actually went around, and when I was doing this, going around and interviewing and learning from VPs, I would always get what were their top 3 recommended books. And I ended up with a list of like 150 recommended books for quality, supply chain, general business. And it was a really good list. And I grabbed about half of them off of there to read just because, hey, if they made it to VP and they think this was helpful,
there must be something to it.
Yeah, a couple of them might still stay with me. Like Blue Ocean Strategy was one of my favorites.
I think you've mentioned that before.
It's a good book.
The one that cracks me up is I was with a client, and they were like, hey, we're going to get all of our department heads and managers this book, and we're going to start them on reading it, and we're going to do monthly meetings to break down the chapters and talk about how we could implement these strategies. And I'm like, oh, what is it? And they said, it's the Toyota way. And I went, oh, so you're going to do the Toyota way here? And they go, yeah. I said, you know how long Toyota's been at that? Do you know when they started? They still are. And do you know the culture that it took to have that kind of rigor, right? That kind of discipline? Do you have and I don't want to burst people's bubble, but I'm like, if it were that easy, everybody would do it. You've got to think about long and hard about what you're asking of your people. And if you have the right, and I guess it goes back to what I said earlier, it was the right time, the right circumstances, and the right culture, and the right solution.
Yep.
Yeah. Reading a book is not going to solve. I mean, it's a start. It'll get you thinking differently, but you still have to put it down and go, okay, what does this look and feel like here? I know what success looks like. How far away are we?
I always wonder if the managers that are the book managers, I luckily never had one, but I always wondered if those actually, if that worked, if that's just, was just making work for people.
Well, and I used to do this. I use the analogy of a gap analysis. I'm like, okay, that's fine. That's where you want to be, but you have to manage from where you are.
Yep.
Not aspirationally. You can't approach your work today and your workforce today with that thing in the future in mind. You have to say, okay, that's our target, or something approximating that target, that future state. But here's where we are. How far, and then you have to build a way to measure how far off you are and go, okay, we need to do these things to get on that path and inch closer to it. And that's the work. People get it in their head, I'm going to read a book, it's going to inspire me, and tomorrow it's going to be different.
Oh, no, the light will shine down.
Yeah, the clouds will part. Yeah. And but a lot of smart people fall for this, and you said you've never had a manager like that, and
I've known them. They just weren't my manager, so I was like,
go. Okay, good.
I had the worst manager, thank goodness.
Oh, I know. I've had them. I've seen them, and like I said, it was a running joke. My colleagues would say, "What book are you reading this week?" I'm like, "Oh, I got a new client, so I've got this one," and it would be some weird book. But yeah, I've got some notes, and I would really love to set up another episode talking about human facts, zeroing in on design, human factors and design, and like what we learned about how humans interact with their environment, and what works and what doesn't work. That would be I think a good one for, I know, for safety professionals, because we often think, look, we're able to make parts. We've been in business for X number of years. Our processes can't be that bad. It's got to be these knuckleheads, right? It's got to be these people. And I think we can maybe try to approach that topic next. All right. Well, hey, where can people find Alex and your whole team and what you got going on? Where do you want them to go to learn more about you?
Best place to go is taproot.com. Check out what courses we've got open to the public. Check out the TapRooT Summit coming up at the end of this year. And
we're going to be there.
Find out about us.
I'm going to be there. What are we going to do? We're going to talk about something. We're going to talk about serious incidents, fatalities. And
yeah, we got PSIFs.
Yes.
So we're going to be talking about that with a couple different people in the group. So
nice. All right. Looking forward to it. And that's in, for this year, 2025, that's in Knoxville, Tennessee, correct?
Yep.
All right.
Done with the flu.
What's that?
We'll be done with the flu by then.
Well, hopefully it'll be gone. The flu, we'll be coming into another October.
It'll be right between the football season. So last week of September, first week in October, it'll be the bye week in Tennessee. So we're good there.
You planned that perfectly.
Yeah, we got lucky.
Well, I'll have links to the website as well as to the summit page as well for everybody who's watching or listening. If you're listening on podcast land, you can watch this video interview. It's very exciting. You can see our backgrounds, all the books that Alex has written, read, and some that I have. But it's over at the SafetyPro Podcast Community site. It's free to join, and you can see all the interviews there as well. And thanks once again, Alex, and we'll talk to you on the next SafetyPro Podcast.